students, this lecture is for grade 8 boys and girls, both wings. Subject is chemistry, chapter number 1, lecture 1, and this is Mrs. Saira Jamal. Dear students, first chapter of chemistry is about the fundamentals of chemistry, and fundamental means the basics of chemistry. So if you want to learn chemistry, it is important to learn the basics of chemistry. The major concepts of chemistry which we will learn in this chapter are branches of chemistry, basic definitions, chemical species, Avogadro's number and mole, and chemical calculation. But before going in the detail of chapter number 1, we have some introduction of science, because chemistry is a branch of science, so we must know about what is science. What is science? Science is the classified knowledge of facts gained through observations, correlation, and experimentation. Our second definition is science is a Latin word came from scienta, which means knowledge. So science is a knowledge which we can attain through study or practice. So dear students, this science which we can attain through observation, I told you, it means that we are doing, when we observe something in our surroundings, so we think about that thing, that how and like why changes takes place in that matter or in that thing. But before going in the detail of chemistry or this chapter, we must know some basic definition or some basic thing, one of which is matter. What is matter? Anything which occupies space and has mass is called matter. And it means that all things which are present in our surrounding, they are solid, liquid, gas, plasma, all are the different states of matter. So it means there are 4 states of matter. About the solid, liquid, and gas, you know in your previous classes and you learned, but plasma is the new state of matter, in which the gases in their ionized state are present. It means the gas is not present as a complete molecule. Actually, the molecules ionizes into atom, and then the atom ionizes into ions. There are 2 types of ions. The negatively charged ions are called anions, and the positively charged ions are called cation. It means when the electrons eject out from an atom, then what happens? The protons only left in the nucleus, proton along with the neutron, but neutrons have no charge. So the nucleus have positive charge and the electrons eject out from the atom. It happens only by heating or by passing electric current through a gas. So it means that the plasma is consist of charged particles. I told you anions and cations. In nature, plasma is present in sun, in star. Human-made plasma is present in plasma TV screen and fluorescent light. Dear student, I have a video, and I'm sure that this video will help you in understanding about the plasma.
Hi, I'm Emerald Robinson, and in this What Is video, we're going to investigate the state of matter called plasma. Plasma is the state of matter that consists of a mass of free electrons and positively charged particles called cations mixed together. Plasma has neither a specific shape nor a consistent volume. In other words, plasma can easily flow into and take the shape of a container and will expand, redistributing itself to evenly fill that container. Although the properties of plasma are similar to those of gases, plasma and gases are not the same thing. In plasma, electrons are released from their orbits around a nucleus, creating a soup of free electrons and nuclei. Because these charged particles are loose, plasma easily conducts electricity and both produces and responds to magnetic fields. Plasma is created when a gas is either exposed to a high temperature or when high voltage electricity is passed through it. The heat or electricity makes the atoms in the gas move so quickly and collide so violently with one another that electrons are knocked from their orbits. Because of the way they are created, plasmas are sometimes called ionized gases. Although plasma isn't discussed as often as solids, liquids, and gases, and was the last phase of matter discovered, you're probably more familiar with plasma than you think. Plasma gives neon and fluorescent lights their glow, is formed during lightning strikes, and of course is present in plasma televisions. Chemists also classify fire as a plasma. Plasma makes up our sun and is visible in the solar flares that erupt from its surface. Because plasma is the stuff of stars, it is the most common state of matter, making up about 99% of the observable universe.
For thousands of how-to and advice videos on any topic, visit monkeyc.com.
Understand well about the plasma, what plasma is from this video. Coming towards the, do you know, this is again students about the matter, and let's see what is here. Do you know the debate going on for centuries about the corpuscular nature of matter? Corpuscular comes from corpuscle. Corpuscle means tiny particle. It means that the ancient Greek philosophers, they thought that all the matters, they are composed of tiny particles, but at that time those tiny particles were not the atoms. At that time they believed that all the matter, they are composed of the tiny particles, and that those tiny particles they consider four things, and then they name them elements. Those four things or four substances or four elements were earth, air, water, and fire. But these are not the new concept. Actually, these are the old and ancient Greek philosophers, they thought that. And which scientist for the first time presented this theory? It was Empedocles. Empedocles for the first time presented this theory, and he said that all the matter, they are made up of four things, and those four things are earth, air, water, and fire. Plato, another scientist, he adopted the Empedocles theory and he coined the term element to these substances. He said that these four substances, we call them element, from which all the matters are made up of. Then his successor, Aristotle, also adopted the concept of these four elements, and he introduced the idea that elements can be differentiated on the basis of their properties. Like some elements, they are cold, hot, wet, dry, so we can differentiate them. One element can be converted into another element by changing different conditions. Like if you want to convert, for example, if you want to convert the clay into dry pot, so first we make a design of that clay, and then we put it in an oven, the water will driving out, and then in turn that clay transform into a pot. It means that if we have water which falls on the earth as in the form of rain, these are the water vapors. These water vapors, and then they become heavy, and then they condensed in the form of liquid, and then they fall on the earth in the form of rain. This means that Empedocles, he said that all these substances or these elements, there are two forces which make these substances to held together, and then the universe came into being. What were those two forces? One he called love, and the other he called the love mean that these are the attractive forces which hold these substances together, but he gave it the term attractive forces. And the second term is called the repulsive forces. These attractive and repulsive forces are very important to keep the substances together, and these substances in turn help in the production of due to these substances, the universe came into being. Students, I have a video regarding the Empedocles theory. I'm sure it will help you in understanding this old concept.
Hello everyone, my name is Demismu and this is my assistant Dafut. Today we'll talk about Empedocles. In the previous videos, we saw how the pre-Socratic philosophers taught the principle of all things was some common element around us, such as water, air or fire. Empedocles brings this kind of thinking to its conclusion, because he includes all the previous elements into his theory. So he takes water, air and fire, plus now he also brings in the earth. He calls these four elements the roots of the world, because they make out all existing things. They are present in all things, in the same way that when we look at the world in general, we see that it is divided into the earth, the heavens, the sun and the ocean, which are basically earth, air, fire and water. So the elements are the building blocks of all things. But what makes these elements come together in the first place? According to Empedocles, there are two forces at work, love and strife. Love makes the elements come together, whereas strife divides and pulls them apart. So we have the four elements and two forces that combine and divide them. Now, at the beginning of the cosmic story, there was only love, there was no strife. All the elements were bunched together into a homogeneous sphere, and no distinction could be made between them. Love was that strong. But at a certain point, strife appeared. The sphere broke apart and the elements became released from their unity. However, love was not idle, it resisted. And so we ended up in a state of constant struggle between love and strife. Love constantly brings the elements together, whereas strife pulls them apart, and their interaction results in our world. We are all creations of love, because we are composed of different elements held together. But the union of the elements is not so strong. We do not collapse into the homogeneous sphere. Instead, we and our world permanently undergo change. Things come into being when love brings the elements together, and they decompose when strife becomes stronger. And finally, there comes a time when strife completely wins over love. All things break apart and no unity is possible anymore. There is only a whirl of detached elements, a vortex in which no thing can emerge. So now love has to intervene in order to restore unity, pulling the elements back together into the sphere. The struggle between love and strife is eternal, but we and our world can exist only when neither love nor strife are too strong in relation to each other. When there is only love, we collapse into the sphere, like a black hole that attracts everything into one point. And when there is only strife, we die, because we get ripped apart by the whirlwind in which nothing can emerge. So the only time life can flourish is between the two extremes. This idea of struggle between love and strife also helps Empedocles explain the emergence of life. Life begins.
So students, I'm sure you understand from this video about the love and strife. Love, I told you, are the attractive forces, and strife, the repulsive forces, due to which the universe came into being. Now, not only the love, not only the strife forces are responsible for the existence, both are required, both are important, and both are necessary for the existence of the universe. Coming toward the main topic, which is chemistry. It is the branch of science that examines the materials, which materials, solid, liquid, gas, and plasma of the universe, and changes these materials undergo. Like changes means that the physical or chemical changes that takes place in these materials, all we study in chemistry. Coming toward the branches of chemistry, there are many branches of chemistry, but the main 8 branches of chemistry we will discuss in this chapter. Number 1, physical chemistry, organic chemistry, inorganic chemistry, biochemistry, industrial chemistry, nuclear chemistry, environmental chemistry, and analytical chemistry. Dear students, these branches of chemistry, the first one is the physical chemistry. So the physical chemistry is the branch of chemistry that deals with laws and theories to understand the structure and changes of matter is called physical chemistry. Physical chemistry, from the name indicated that all the physical changes that takes place in a matter and their effect on the composition or structure of matter. The laws and theories we will discuss it in the chapter number 5, that there are certain laws and theories which are related with the physical properties of substances, like their volume, temperature, pressure, and number of moles. There are certain important laws, Boyle's law and Charles' law. Initially, we will discuss those laws in chapter number 5. But over here, keep this in your mind that there are certain laws and theories which help us in understanding the changes of matter, like how the matter changes from one state to another change, like from liquid to gaseous state, or from gaseous state into the liquid state. Coming toward the second branch of chemistry, which is organic chemistry. Organic chemistry deals with the substances or with the compounds which are from natural sources, because mostly you have heard this, that the doctor said that always use organic food, which is natural food. So it means that organic chemistry deals with those substances which exist naturally, like coal, petrol, natural gas. All these exist in the universe naturally. So the branch of chemistry that deal with substances containing carbon is called organic chemistry. Coal, petrol, natural gas all contain carbon containing compounds. So all these we study in organic chemistry. However, there are some compounds, although they contain carbon, but we consider them as inorganic compound. These are carbon dioxide, carbon monoxide, carbonates, and bicarbonates. Why we consider them as inorganic compound? Because in most of their properties, they resemble inorganic compounds. Although they have carbon, but due to their resemblance in properties with the inorganic compounds, we study them in inorganic chemistry. The third branch of chemistry is inorganic chemistry, the branch of chemistry that deals with elements and compounds other than carbon containing compounds are called the inorganic compound, and the branch is called inorganic chemistry. Sulfuric acid, hydrochloric acid, nitric acid, they does not have carbon in their formula, so we study all these compounds in inorganic chemistry. Fourth branch is biochemistry. Bio means life, and chemistry means the physical and chemical changes that takes place in the substances. The branch of chemistry that deals with physical and chemical changes that occur in living organisms. Living organism may be animal, plants, human beings, etc. Microorganisms even. So all the changes takes place in those living organisms. We study them in biochemistry. Fifth branch of chemistry is industrial chemistry. So the branch of chemistry that deal with the method and use of technology in the large scale production of useful substances is called industrial chemistry. For example, if we are going to prepare cement or manufacture cement, so cement we always prepare or manufacture in industries because a large scale of cement is required for the construction of buildings and many other like roads, etc. So the cement production of cement, there are two important processes by which cement can be prepared in or manufactured in industry: wet process and dry process. So some industry use wet process for the production of cement, and some industries use the dry process for the production of cement. But as cement is produced on large scale in industry, so we study the production of cement in industrial chemistry. The sixth branch of chemistry is nuclear chemistry, and again, nuclear comes from the nucleus. So all those compounds which are radioactive means they emit radiation. The process is called radioactivity, and those substances are called radioactive substances. Isotopes also we study them in nuclear chemistry. Actually, the branch of chemistry that deal with the changes that occur in atomic nuclei is called nuclear chemistry, because the changes in the nucleus of an atom causes these radiations to emit out, and then we study those changes in nuclear chemistry. The seventh branch of chemistry is environmental chemistry. It means that this branch of chemistry deal with the chemicals and toxic substances, from where those chemicals and toxic substances come out, from the burning of from burning of the fuel in automobiles engine, from industries, from factories, from burning of coal. These toxic substances come out and they pollute the environment, and then their adverse effect on human being is in the form of the global warming, greenhouse effect, acid rain, which pollute the environment, which cause adverse effect on environment, and then that environmental changes affect the human beings. So all these effects we study in environmental chemistry. Analytical chemistry, analytical comes from analysis. It means when we are performing any experiment and we use some method and we use some instruments to determine the result, or to determine the how to take or to collect observation to check the composition of matter. We study all those methods in analytical chemistry. So analytical means analysis. Dear students, hope you understand the branches of chemistry. We can understand the branches of chemistry with the help of some examples. Inshallah, I will upload those changes in my second lecture. And inshallah, you will understand the branches of chemistry well from those examples. Thank you.